Hey guys, Mrs. Lyons here. I am with you and I'm going to go over the single replacement homework. Um, Take a minute, and if you don't have this uh, list of polyatomic ions and activity series of metal, take a screenshot of it with your phone if you have access, print it out. But you will need to refer to this, and I probably won't pop back and forth between double screens. I'll just kind of say, oh, this is more reactive than that when we get to doing these single replacement reactions. Okay, so remember, single replacement reactions sometimes happen and sometimes they don't. Okay, and I like, and I know it's the old terminology because it's just so last year, but I like referring to our activity series as the RIS factor of our elements, meaning that, the person with Riz is the popular person. It's the person you want to hang around with. Okay. So likewise, the metal or the element with the most Riz is the element that other elements want to bond with. Okay. And what that means is, let me pull this over here one more time. If you're looking at, it won't let me. Oh, here. Because it's stuck. Here we go. If you're looking at the activity series, for example, lithium in this activity series, okay, so, lithium is the most reactive. It's going to want to be in a compound more than any other thing. Okay, so as we look at this, and I'm going to put my page over on my other screen so I can see it. Hopefully you have a screenshot of this so that you can also see it. All right, so let's take a look at our single replacement reactions. Okay, so remember what we've got to do is we have to look at the metals, okay, or you have to look at the element. Okay, so in this case, calcium is a metal, magnesium is a metal. So we have to look at our activity series and find calcium and find magnesium. So calcium is higher than magnesium on the activity series, which means that calcium is going to switch places with the sulfide, and the magnesium is going to end up alone. Okay. Now, we do need to write this in a chemical equation. So when we do this, in all of these reactions, it's going to be the same thing. The metal, so calcium, is going to be a solid. And then the compound, so in this case, magnesium sulfide, magnesium's +2, sulfide is -2, so MgS. The compound is dissolved in water, which means it's aqueous. If you just put two solids together, 90% of the time they're not going to react without adding a lot of heat. Okay, so we put this compound in water and then we see a reaction. Okay, so since there's a reaction, I have to predict my products. Calcium forms a +2 ion, sulfide -2. So I end up with CaS, which is aqueous, dissolved in water, plus magnesium metal, which is a solid. All right, and this one is pretty sweet because it's balanced for us already. All right, sodium plus silver chloride. So sodium's the metal, silver's the metal. Sodium is way above silver, so our product is going to be sodium chloride plus silver. Okay, so we have sodium metal, so sodium solid, plus silver's +1, chloride's -1, AgCl, it's aqueous. All right, and that's going to produce sodium's +1, chloride's -1, so NaCl, aqueous, plus silver solid. Okay, this one's balanced too. I like these. All right, number 3, iron 2 sulfide plus potassium. Again, potassium, iron. Potassium is way above on the activity series, so we're going to end up with potassium sulfide plus iron, and we don't need the Roman numeral. Okay, so iron has a +2 charge, sulfide has a -2 charge, potassium has a +1 charge, sulfide has a -2 charge. So we get FeS, and that's aqueous, remember, dissolved in water, plus potassium metal, which is a solid, and that's going to produce K2S, aqueous, dissolved in water, plus Fe, solid. All right, so let's see, is this balanced? This one is not balanced, but it's not hard because I just need a 2 there to balance out my potassium, and I'm good to go. All right, let's see. Excuse me. All right, up next we have barium and aluminum nitrate. So if you look, barium and aluminum are metals. Barium is higher on the activity series. It's got more Rs. All right, so we end up with barium nitrate plus aluminum. So aluminum is +3, nitrate is -1, barium's +2, nitrate's -1. All right, so we have barium metal, so barium solid plus aluminum nitrate is a polyatomic ion from the back, NO3, 3. Our compound is aqueous, dissolved in water, produces barium nitrate, aqueous, plus aluminum solid. So let's see. I have 2 nitrates here and 3 here, so I have to do the 6 common multiple thing. So I need 6. So I'm going to put a 2 there. That gives me 6 nitrates. If I put a 3 here, that gives me 6 nitrates. So I need 2 aluminum and 3 barium. All right. Ooh, check this one out. Okay, chlorine is not a metal. So chlorine can only trade places with iodide. All right. So that's important to note. And if you look at your activity series, chlorine is above iodide. So it is going to happen. So we're going to end up with potassium chloride plus iodine. Make sure you change the ending from iodide to iodine when it's an element. Potassium's +1, iodide's -1, potassium is +1, chloride is -1, so we end up with Ki, aqueous, plus chlorine is a Hoberfinkel, so Cl2, it's a gas, plus KCl, aqueous, plus iodine, Hoberfinkel, diatomic, I2, and it is a solid. All right, so I have 2 iodine here, only 1 here, so I'm going to put a 2. Now I have 2 potassium. I have 2 potassium. Let's see, 2 potassium, 2 potassium, 2 iodide, 2 iodide, 2 chlorine, 2 chlorine. Okay, good deal, balanced. All right, zinc plus lead chloride. Let's see, so if we look at zinc, zinc is above lead. So we're going to end up with zinc chloride plus lead. All right. This tells us lead is 4, chloride is -1, zinc is +2, chloride is -1. All right, so we end up with zinc solid plus PbCl4 aqueous produces ZnCl2 aqueous plus Pb solid. So we've got 2 chlorine here, 4 there. So if I put a 2 there, that balances out my chloride as 2 there, and I am balanced. We are not talking acids. That's cool. Barium plus water. Remember we said write water as HOH, because then you can look at your activity series And if you do, barium is above hydrogen. So this is going to be barium hydroxide plus hydrogen. Okay. So barium's +2, hydroxide's -1. So we end up with barium solid plus HOH, which is a liquid, okay, because it's water. And then we end up with BaOH2 aqueous and H2 hydrogen gas. All right, now, when you balance this, these hydrogens correspond to the H2. These OHs correspond to these OHs. Okay, so if you look, I've got 2 OHs, 2 H2s, a 2 here balances it, and I'm done. All right. We do not need to do HCl. We're not doing acids. Gallium bromide plus fluorine. This is another one of those where you have to look. Fluorine's a nonmetal. So it is going to happen because fluorine is higher up. Okay. So we're going to end up with gallium fluoride plus bromine. Okay. So gallium is +3, bromide is -1. So gallium bromide is GaBr3 aqueous. Now, this is an interesting reaction because fluorine is a Haber-Finkel, so it's diatomic, it's a 2. It's also a gas. So when this reaction is done, we kind of bubble this fluorine through, and it takes the place. So we end up with gallium fluoride, GaF3 aqueous, and we end up with bromine liquid because bromine at room temperature is Br2 liquid. All right. So if you look, we've got 3 bromine, 2 bromine. So I need to do 6. So 2 times 3 is 6. 3 times 2 is 6. So let's see, I need 2 galliums and 3, let's see, wait a minute. And 3 here. And I'm balanced. All right, last one. Remember, we're going to do HOH as water. All right. So water, hydrogen, potassium is above hydrogen, so we're going to end up with potassium hydroxide. Plus hydrogen. Okay, because potassium takes hydrogen's place. All right, so we start with HOH plus, and that's a liquid, plus potassium solid. We're going to get potassium hydroxide, so KOH, and hydrogen gas, so that's going to be H2G. Now this one, since we've got 2 hydrogens here, we'll only have 1 here. I'm going to put a 2 here. And then I've got 2 hydroxides, so I need a 2 here. And now I've got 2 Ks, so I need a 2 there. And I'm balanced. All right, you guys, I know that was really fast, but I wanted to just kind of give you a work through so you can kind of look at the way that I go through these. All right, I hope this is helpful. Have a wonderful day, and I will see you in class.